Okay, welcome everybody to this joint EHP Solar Heat Europe webinar. Pauline, the floor is yours.
Thank you very much, Valerie. Good afternoon to you all. And on behalf of Euroheat Power and the Bring It Home campaign, it is my pleasure to welcome you to this joint webinar with Solar Heat Europe. I represent Euroheat Power, the association promoting the growth of sustainable district heating and cooling. And we launched the Bring It Home campaign in November 2024 to address the elephant in the room of the EU's energy transition, heating and cooling. As you know, 42% of EU energy is used in buildings, which is 80% of it heating and cooling, and 26% of the EU energy is used in industry, of which 60% is heating and cooling. And this energy, unfortunately, is still overwhelmingly coming from costly imported fossil fuels. So for this reason, we brought 6 partners and 6 supporters that you can see on the screen to work towards common objectives: safe, comfortable home, competitive industry, and starting with clean and efficient heating and cooling. So within the campaign, we've had various discussions in the past year under the auspices of 6 Parliament patrons. So Sigrid Fries, Thomas Pellerin-Carlin, Benedetta Scuderi, Martin Heusig, Sean Kelly, Jutta Paulus, all supporting a clean heating and cooling transition. And together we have contributed to put heating and cooling in the spotlight to accelerate the transition. And the upcoming European Commission strategy on heating and cooling is really a testimony to this. We will hear about that in a short while. And it will be key to implement the Fit for 55 package policies and bridge any gap that may still there. So there is a lot of work ahead of us, but also a lot of opportunities to make this transition happen. And we have ready to scale, made in Europe, clean heating and cooling solutions. And today we are here to talk about one of those, which is solar thermal district heating. And today's webinar is very timely, as actually DG Energy is working on its strategy. And we will show you with our speakers that not only clean heating and cooling on the ground is achievable, but that there are many projects already that we can learn from. And our speaker will show examples and show what is needed to scale up solar district heating at a faster pace. So in terms of housekeeping, this webinar is recorded. The recording will be available after the session, and you can ask your question using the chat box. Thank you very much, and I will now hand the floor to Valérie, wishing you a very successful exchange today.
Thank you very much, Pauline, and on the behalf of Solar Heat Europe, a warm welcome from my side too. I'm Valérie Séjourné, the Managing Director of Solar Heat Europe, and here I will just give a few brief introduction of what Solar Heat does and about the program of today. So, well, in terms of where we stand, there are 19,000 district heating networks in Europe today. You see that half of those are still running on fossil fuels. There is some share of renewables, essentially bioenergy, but also geothermal, solar thermal, which are being used. Solar thermal is a relatively discrete share for the moment, 0.2%, but the potential to grow for our technology is definitely big. We see at the bottom of the slide that the use of district heating is very broad in terms of penetration, with a lot of penetration from in the north of Europe. And you see the different other nuances elsewhere. There is still very much potential for new district heating to also grow, and there is a pathway with the Energy Efficiency Directive for that. What the EED also is giving us in terms of journey is the way, the mix of technologies that should feed this district heating and how this mix should evolve towards 2050. And you see with the yellow line, this is a visualization of Article 26 of the TED that the mix of technologies to use for district heating definitely must be based on more and more renewable heat, such as solar heat, but also waste heat and cogen. So the potential with the yellow line that you see with renewable heat is what we would like to talk to you about, and especially the solar thermal potential, which we represent in Solar Heat Europe. Solar Heat Europe is really the voice in Brussels of all solar thermal industry actors, project developers, research institute. So I will here with my colleagues share a few recent examples of the technology. Where do we stand now in terms of use of solar thermal? For district heating, there are in Europe 262 cities using solar heat. You see the energy which is produced from those. Denmark, we actually were quite keen to organize this webinar during this semester because it's the presidency of Denmark for the EU Council, and Denmark happens to be really the world record country in terms of use of solar thermal district heating. There are 124 cities using solar heat in Denmark. I have a couple of colleagues from the Danish environment who are available for some questions, and I've been borrowing a few visuals from them. This is the Plan Energy and DTU. But you see that across Denmark, there are different district heating of different sizes. That's already in 2009, the first district heating was created, and the penetration has been growing well, and it's really fantastic to hear the chairman of the Solar Thermal District Heating Association in Denmark saying that 30 years after, the solar thermal field continued to produce as the very first day. So really a reliable and promising technology. So without further ado, I will leave the floor now to Mathieu Balu from the European Commission. He's going to introduce us to the policy environment in which we work with, of course, the implementation of the Fit for 55, which is happening now, coordinated by the Commission and implemented by the Member States. And Mathieu is also holding the pen for the upcoming EU heating and cooling strategy. So, and after that, we will have a few examples from our members to illustrate the recent examples of solar thermal district heating. So, Mathieu, the floor is yours, and thank you very much. I will stop sharing now. Voilà.
Thank you, Valérie, for the introduction. And thank you, Pauline, as well, for organizing this jointly. Good afternoon, all. I work in the Directorate General for Energy of the European Commission, indeed specifically on renewable heating and cooling. You heard the numbers already. Half of our energy use comes from heating and cooling. 2/3 of our natural gas consumption is also related directly to the use of energy for heating and cooling. So it's a decarbonization issue, it's an affordability issue, it's a major energy security issue for Europe. And if we want to cut our dependency on energy imports, it's very clear that heating and cooling is the first lever. And it's not only about the amounts, about the supply, but we use that heating and cooling in a very inefficient way. And the system costs of the way we produce and use heating and cooling in Europe are very high. We have an almost virtually infinite supply of local sources, direct renewable heat, solar, but also geothermal heat, ambient heat. We are wasting enormous amounts of heat that are emitted by industrial processes, by cooling processes in general, and that we do not recover. The way we use it as well, the temperature produced is not necessarily matched with the best use in terms of the temperature that would be most relevant, and district heating and cooling, which is a very efficient way of distributing that heat, of gradually integrating clean sources of heating to replace fossil fuels and to cover demand in cities, for instance, where you have dense demand of heat, is not yet developed sufficiently, is not expanding, and is not decarbonizing fast enough to match our ambitious decarbonization objectives. So we need to accelerate what we are doing to really deliver on all these objectives. There is already a very comprehensive regulatory framework in place in the European Union. We have targets. We have targets for renewable energy and specifically for the use of renewable heating and cooling. And we have specific targets for renewable energy in district heating and cooling. We have legislation that establishes a long-term pathway for the decarbonization of district heating and cooling networks, which have to gradually incorporate more and more renewable energy and waste heat to be able to receive state aid. So that trajectory is there. We have other elements related to the accelerated permitting of renewable energy projects, for instance. We have pressure on industrial sectors to use more clean energy through carbon pricing, for instance. A lot is already there. But we still see that the share of renewable energy in the EU has increased by significantly less than 1 percentage point per year on average over the past 10, 15 years, why we would need 3 or 4 times that to be in line with our renewable energy ambitions for 2030. And we know we're currently discussing climate targets for 2040. We will need to at least keep the same pace or accelerate if we want to be on track with those decarbonization objectives. So how do we do that? There is a need for a comprehensive vision of that sector and the role it can play in general in the energy system. What is the place of heating and cooling? And then there's a need for specific actions to support, to accelerate the implementation, to bridge the gaps, to accelerate the deployment of heating and cooling solutions. And this is why the European Commission is working at the moment on a strategy on the decarbonization of heating and cooling. This strategy aims for decarbonization and, of course, affordability. It was announced in a strategy called the Affordable Energy Action Plan earlier this year. And we intend to publish this strategy in the first quarter of next year, together with an action plan that will promote electrification in the energy system. So these two things go hand in hand. We know that the energy system of tomorrow will be based on large amounts of renewable electricity. And we need to create demand for that electricity. But we know also that direct renewable heat, in particular, is essential to complement electrification, to offer also less costly solutions, reduce the pressure on the electricity system, and can, for instance, combine with thermal storage to offer flexibility to that highly electrified energy system. And again, district heating and cooling systems are at the core of that system. They are pivotal elements that can deliver flexibility, that can blend in sources and reduce the pressure on electrification. So with the strategy, we want to bring that comprehensive picture. The first element is really visibility, attention, and that overall narrative, because heating and cooling has being less visible. The awareness is probably lower than on other aspects of the energy system. Then we want to look at the available technologies, solutions. What are their specific use cases? What are the specific barriers that they face in terms of deployment, but also in terms of promoting EU-made manufacturing? We want to support energy efficiency. Energy efficiency from the system level to the technology level. So there's already plenty of regulatory tools in place, but really we want to strengthen especially that system dimension, support local planning of heating and cooling, guide local authorities to make decisions on investments to foster the most efficient solutions where they make more sense. And again, district heating and cooling has a very central place there. We want to unlock options to deliver flexibility, and I mentioned it already, but thermal storage, which combines very well indeed with solar thermal, is one of the best options to deliver long duration energy storage in particular, and to bring flexibility to that system. And the main thing is that we really want to unlock the investment that will make this transformation possible. We know that there are specific barriers to large projects in particular. There's a perceived risk for investors related to the matching of supply and demand of heat. They are very local. You need to guarantee that the heat supply will still be there. You need to guarantee that the heat demand will still be there. So we want to work on these elements as well. And the strategy itself, as I mentioned, will be the demonstration of the long-term commitment to this system transformation. That's it. So an overall very broad and ambitious agenda, and we're really working on this as we speak, which is why I will not be unfortunately able to stay until the end of this webinar because of this.
Thank you, Mathieu. And really, you know that you have our support in SolarHeat Europe in your Region Power to help you with this strategy. The visibility of the heat agenda, heating and cooling, is really key. So that the fact to have an electrification action plan together with the heating and cooling strategy side by side to show the complementarity of the different technologies and all the mix of good solutions which can arrive at the transition will be definitely critical and important. So thank you for that, and we are happy to support you. We will talk permitting, we will talk acceleration of renewables in the examples, but hopefully you can still benefit from a few slides of my colleagues who will present now. So without further ado, I would like to now introduce Lucy Nebu, who is my first speaker. Lucy from Euroheat, she's business development for the DACH region, and also in charge of public affairs for Euroheat. So Lucy, if it's okay for you to share your slides, and then we will have 5 speed dating presentation with 5 different members of the network. So over to you, Lucy.
Thank you very much, Valérie. So I'll share my screen right now. Yep. Thanks a lot. Does it work for you? Yes?
Yes.
Excellent. Thanks for the feedback. So hi, everyone. Thank you for joining this webinar. My name is Lucie Nebu. As introduced by Valérie, I am doing business development at Euroheat. So Euroheat is a renewable heat supplier for 2 types of customers, actually, industrial sites and district heating networks. For each of these customers and for each project, we combine and design, finance, and operate tailor-made renewable heat systems, including large-scale solar thermal, which is very important to us, which we combine, depending on the project, with other virtuous technologies, which we've mentioned today already: storage, electrification, but also heat recovery, biomass. The goal being achieving the highest possible coverage of the heat demand at low temperature of our customers, and going for the most important, the biggest possible decarbonization of those targets. So I'll dig into the references which we have at Euroheat for renewable district heating. So basically, we have 40 megawatts in total in operation and 2 plants already supplying heat for district heating networks. This is in the city of Pont, so it's about an hour away north of Bordeaux. And this solar thermal 1.5 megawatt plant, combined with a water storage, supplies the network in combination with a biomass plant, which also uses our storage. So I think that's something interesting here, is that basically Euroheat really pushes for multi-energy operation, always in this direction of achieving the best possible decarbonization rates for the customers. In this case, maybe importantly about the business model. So this is a project where the customer is the network operator. So in this case, it is Dalkia. It was subsidized by the French ADEME, and on top of it, it also received regional funds. I know we will discuss on the funding issues after that, but I think it's important to say that the funding was crucial for the project to be competitive and to trigger the decision for the municipality. And as I say, the double integration with the biomass boiler. Second reference which I wanted to present is the one on the city, for the city of Narbonne. So comparable size, a bit bigger, 2.8 megawatts power installed of solar thermal, combined also with the heat storage. What's interesting here is that there was a lot of flexibility in the integration, because we had to implement the solar thermal field at the end of the network, so to say. Comparable model in terms of subsidies also, a 25 years supply contract. So we probably won't have the time to go into these details, but Euroheat offers a heat as a service. So basically we financed the plant, also cover the financing part. And so we proposed to the customer, in this case Dalkia again, heat contract. And another aspect of this project, which has been recently implemented, it is the power to heat part, which we have added on the Narbonne project. So basically, we've installed an e-boiler, a very classical one, nearby the site. And so the water storage, which we have implemented on site, now can also be fed in by the e-boiler when it is activated to according to the flexibility requirements of the grid. So this is a test phase. So basically, we are not taking all the benefits yet of what it could bring. The idea is really that we want to combine solar thermal more and more with that type of technologies, because we are convinced, and it was also said earlier, that the combination of electrification with direct renewable heat is key to achieve the decarbonization targets. So basically, today we activate it not so often, and the idea in the midterm is to activate it as much as possible when the electricity prices are low. And just to conclude, we have at Euroheat, we really want to support the district heating network operators and companies with different size of possible systems, of possible solutions, from solar thermal combined with water storage up to very high levels of coverage with long-term storage, but also biomass if relevant, and a significant part of electrification. And that's it from me. Thank you very much. I hope I was not too long.
Thank you, Lucy. Well done. No, that's a great start of our series of intervention. So you stay with us for the panel. So now I would like to give the floor to Guglielmo Sioni from TVP Solar. Guglielmo is also our president in Solarity Europe, but is managing the sales in TVP. Guglielmo, over to you.
Okay. I will share my screen. I have quite a long presentation, but I will just run through it, not really go through all the slides. I don't know if you can see that.
Yes, we can.
Yeah, okay. So what you read here, hot water at 120 degrees for district heating all year round, is really our statement and our vision. But it's not an easy feat, because, you know, solar thermal, being solar, first of all, requires the sun. So clearly doing it during the summer or during the good season or in sunny places is not difficult and not unheard. But what we're trying to do is to extend as much as possible the possibility to use solar thermal all year round. And to do that, we had to create a whole new technology since scratch. And this is what you're seeing on your screen. These are the high vacuum flat panels. This is a technology that is owned by TVP Solar. We are the sole manufacturer in the world. It's also one of the most expensive solar panel you can buy, but eventually our value proposition is being well accepted, because in recent years we have already built a number of plant, commercial size plant, megawatt scale plant for clients in the district heating and also in the industry sectors. So I will just jump here. This slide, Magdalena, that will come after, knows very well. And I'm very proud to show it. This is a report from the International Energy Agency Task 68 that has compared more or less to all the different types of collectors. And you see that our collector, the high vacuum flat plates, stands out because effectively is the best performing collector in the world. And this is what we start from, but then of course we need to add to this technology a number of additional features that we have developed over the years to extract as much as possible from this extremely efficient device. So I just will show you quickly some pictures, but then I will focus on one particular project, the largest that has been commissioned in the last years. This one is the project in Germany. It's a 4 megawatt plant for a district heating network in a small city, Sondershausen. It's been up and running since 2024, has been delivering heat to the network stably over the year. Of course, over the year, it means mostly during the summer, but also during winter, at the required temperature of the network. I won't stop here commenting all this little data, but I be assured that this presentation will be available to you. So if you want to go through and then ask questions later on, for sure you can do that. This is a system that has already a significant thermal energy storage, 1,000 cubic meters. Valerie was mentioning storage. Also, Lucy mentioned storage. Because storage is really the way we can maximize the use of solar thermal, especially during the summer months. We are focusing here on a daily storage that will allow the system to work even 24-hour a day during the summer months. There are other types of storage, long-term ones, but we haven't really explored them like they did in Denmark so far. But anyway, this system will deliver and is delivering 3 gigawatt hour of heat at the required temperature, up to 93 degrees, in a cold place with low irradiance like Sondershausen in Germany. I will just move through. These are some pictures. I don't want to take too much time from our colleagues that need to speak as well. But the most meaningful project that we have now is this one. It's in the Netherlands, so even lower irradiance than Germany. And this is the largest project brought online in recent years. Now there is another one that is being built in Germany. I think they will commission it pretty soon. But so far, this 30 megawatt plant is really the demonstrator for large-scale district heating applications for our technology in particular. And it's made up of 48,000 square meters of collectors distributed over 12 hectares and produces hot water, of course, during the summer at 75 degrees, during the winter at 93 degrees. And it's a big project. And as we were, also Lucy was mentioning, this project has been developed by a local company that is mostly a PV, photovoltaic developer. And we, as TVP Solar, also own 30% of the project ourselves and provides the heat to the city of Groningen, in particular to the district heating company Wartestad, operating in Groningen. And during the summer, now it's up and running, can deliver 100% of the heat needed by the cities over the 24 hours. So it makes the city really completely independent during the summer, during the winter a bit less. In fact, what I would like to show you before we close this very speed dating is another thing that is on my screen now. You can see how the system is performing right now. I hope you can see my my Chrome screenshot here. This is really the kind of information that you can take out from our system. And why we insist so much on data? This is the month of August, for example. You see the green line is the irradiance available, and the bars, the pink bars, are how much energy has been produced every day during the month of August. So, for example, in total, in August, we have produced 3 gigawatt hours, 2.99. And of course, during the summer, it looks nice. But let's go to November. You see that in November, the irradiance is much, much lower, going to zero many days. But even like this, TVP solar system can produce heat at the required temperature, or it will not be delivered. Now we have this is important for those who are interested in having a solar thermal facility on their district heating operators, etc. This is a very sophisticated system for delivering heat to the network directly, because we have a specific protocol for us to be allowed to deliver the heat on the other side of the heat exchanger of the client. And the client has not invested one penny in the project. Vartestad is just buying the energy on the basis of a heat purchase agreement. Now we will see, probably Vartestad might be interested also, I don't know, in taking over the plant at some point. But in principle, there is no need for it. This is a typical project financed project with a long-term loan provided by Triodos Bank, and with a very careful system for checking the performance and assessing that the plant is delivering exactly what it is required to deliver. It's a big investment, it's 25 million euros, and therefore it needs to be repaid in full, and it requires a lot of attention to minimize all the downtime and to make sure that all the expected performance is actually reached. So I will just close it. I will just close it with this picture. The thermal storage is here. You see 20 meters high, 6,000 cubic feet. And this is the scheme. Okay, I won't take more time. Thank you very much.
Thank you, Guglielmo. With lots of passion in our membership for that project, which is well-deserved. Alejandro, now from Spain, the CEO of Abora Solar. You have some interesting hybrid technology cases to introduce. Over to you.
Hello, everyone. Can you see my screen?
Yes.
Yes, now you can see it. So, hello, everyone. My name is Alejandro Lamo, CEO and founder of Abora Solar. Maybe someone of you know our technology. I'm going to show you what is different in our technology and two successful cases in district heatings, but also we can use our technology in industry applications or tertiary sector. So first of all, we are a Spanish manufacturer, so we fully manufactured in Europe. This is really strange when you use photovoltaic because our solar technology is a hybrid panel. A hybrid panel means that generate electricity and heat in only one panel. So when you assume both generation, electricity and heat, we have achieved an efficiency of 89% of efficiency. So 70 plus in thermal plus 20 more or less in photovoltaic, we can convert 89% of the total irradiation coming to useful energy. So these numbers are important. That is not the numbers I mentioned you today. Is the certification, the Solar Kimar certification obtained that guarantee these numbers. I have already mentioned, but I want to emphasize it that we are European manufacturer. It's really strange, but yes, we are. We have the manufacturing line in Zaragoza, in north of Spain. And the most interesting thing of our technology is the more energy you can generate, the more savings in euros, in economical, in energy and emissions you will profit it. So in most of the cases and in Europe in general, we don't have enough roof space available to generate all the energy, thermal and electricity that we consume in the buildings. And it's really strange because in single family house, we have enough roof space to generate all the energy we consume, but in the large applications in like the industries or district heating, we don't have enough ground of space on the roof to generate all we need. So we have to generate as maximum as possible. So I'm going to show you the very fast schema or really simple schema we use in high temperature applications. So we have our PVT generation that is the heat source of our water heat pump. And these water heat pumps used to work between 70 and 90 degrees. So the standard district heating already are working, and the project we have already done works between 70 and 90. So our panels are working between 10 and 30 degrees. So you can imagine the efficiency at these low temperatures is huge. And to jump from 20, 30 degrees till 90 degrees, we use a water heat pump. But what is important to make sense this combination is that the electricity consumed this heat pump is lower than the electricity generated by the panel. So here we have a positive installation in terms that we generate a lot of heat at high temperature, but also we generate electricity for other consumption in the industry or in the district heating. So it's interesting that the COP of the heat pump will be really high because we have more temperature than the ground of the ambient, and the PVT technology is working really good because the low temperature and is generating a lot of energy, thermal and electricity. So I want to share with you today two examples. This is the largest PVT installation we have done in 2024. This is in middle of Spain in Cuenca. And the problem they have in this district heating is that they don't have more space available to produce more energy, because if they have more space, they will install more panels. Here we have 1,090 PVT panels installed, working since 24. The thermal generation during 1 year is 2,141 megawatt hour thermal, plus 630 more or less megawatt hour in photovoltaic. When you assume both technologies per square meter, is the technology with the highest density of production in thermal and photovoltaic. But most of our clients told us that in Spain it's sunny, so we can produce a lot of energy, but also we have real cases in Germany, in Poland, in France. And this is the last installation commissioned two months ago, more or less, with 120 PVT panels. So district heating is not needed. That is the largest installation. Could be a small installation for a neighborhood with 50 or 100 buildings, and you can supply part of the energy. So we don't recommend to design the installation to cover 100% of the thermal demand. No, let's do as much as profitable as possible. So the more profitable, the best for the payback, and this is what we are looking for. So my presentation is really short. I want to respect your time, and if you want more information, here we are in Abra. Thanks to SolarHeat Europe.
Thank you, Alejandro, for keeping the time and introducing the hybrid technology of PVT. So now I would like to invite Rainer Tropman. I love the tour of Europe that we do, not only with the cases that we have from district heating using solar thermal, but also from our own companies, from this time Austria, Gasokol. Over to you, Rainer. Thank you.
Okay, hello, good afternoon from my side. I try to share my screen. I hope you can see the presentation. Is it okay? Well, I'm going to talk about solar district heating for villages. In my presentation, I want to focus on rather smaller systems for villages and not the big ones for the big cities. So I'm going to talk about kilowatt instead of megawatt. The potential for these smaller systems is huge. Imagine in Austria, we have more than 2,000 district heating systems, in most cases biomass fired, and not all of them have solar thermal systems for summer. Let me say some words about Gasocoal. We are on the solar thermal market since more than 40 years, producing our high performance collectors in Sachsen. It's the Austrian Sachsen. It's a small village in the middle of Austria. And we are selling our collectors all over Europe, from Italy to Sweden and from France to Romania. And we are also producing large-scale collectors since more than 10 years now, when we started the first project with an installation of more than 1,000 square meters. Let me show you some examples from Austria. There is the biomass heating plant in Sachsen, which is in operation, the solar thermal field, since 2007. So it was the first one that we installed, and we at Gasocoal are also running, we are operating this solar thermal plant and selling the heat to the biomass heating network here in Sachsen. The newest one is in St. Georgen am Walde, which is also a village with about 2,000 inhabitants, not too far from here, which is from this year. Here we have a ground-mounted system with a bit more than 300 square meters, or a bit more than 200 kilowatt. Coming to another range of villages with 500 inhabitants, one in the federal state of Burgenland, commissioned last year with more than 500 square meters. It was an exchange of an old 25-year-old system, and the new one in Mönchsdorf. You can see the available space is not too big. So here we could install about 160 square meters, a bit more than 100 kilowatt. So it's just talking about kilowatt and not megawatt or tenth of megawatt. The largest installation with Gasocoal high performance collectors is in St. Ruprecht in Styria, also in Austria, commissioned in 2020 and extended in 2023. Now the whole installation has about 2,000 square meters, or 1.4 megawatt. So we also have our collectors in megawatt installations. Well, not only talking about Austria, we have, I show you two projects from Switzerland, Madstetten from last year and Rohrbach from 2019. As you can imagine, in Switzerland, ground-mounted system, it's very, very rare, nearly impossible, because the space is very expensive. So we have to deal with the available roof, which is a big one in Madstetten with close to 800 square meter collector area. And in Rohrbach, it's a smaller system with 200 kilowatt. And also Germany is represented in my presentation. In Kirchhardt and Mauer, two small cities with 6,000 and 4,000 inhabitants. We are happy that there are Gasocoal collectors in two installations, the one with 120 kilowatt and the next one with just 30 kilowatt. So this is the end of my speed dating. Whenever you have questions around solar thermal for small systems, we are happy to help you and to answer your questions. Thank you.
Thank you very much, Rainer, for keeping to the time. Interesting to see smaller size of projects. Okay, so now we are arriving at our last speaker for the speed dating, and this is Magdalena Berberich, who is the CEO of Solites in Germany, who is going to take the floor to update us on the market, which is quite dynamic, Germany. Over to you, Magdalena. Thank you.
Yes. Hello together. Thank you for the invitation to this webinar. I hope you can see my screen now.
Yes.
Yes, okay. So I want to give a quick overview over the German solar district heating market. And yes, You can see our statistics at Solites. We are a research and consulting company in the field of solar district heating, and we do these numbers, do the statistics in this map from Germany. Here it's the update from March, but the numbers are the newer one from November 2025. And we see that in 2025 there are 10 new systems went into operation with 67,000 square meters of collector area. And it's a good development because in 2024 there were just 3 new systems with around 10 square meters. So this is a really good development, and we see the more plants are in realization. It's 10 more systems we know at the moment, and it's around 132,000 square meters of collector area. So in total, we have now 71 systems in operation, and these are the larger systems. So sorry that the Gasocoal systems are not here in the map. It's just systems more than 500 square meters of collector area. And we see here in the numbers that the systems get bigger. So for example, we have this plant in Leipzig in Eastern Germany, where the municipality of Leipzig are installing or are in the end of installing a big collector field with 65,000 square meters, and this will make a solar share in the city and the district heating of Leipzig of around 2%. This is an older picture. It's from the planning phase. I'm sure it looks different now, and the collector field is already installed, and it should go into operation in the next weeks or month, as far as I know. The collectors will deliver heat directly in the district heating with up to 110 degrees. What are the factors in Germany that solar district heating is successful? For example, the local heat planning is mandatory. So it's defined where is district heating or where should be solutions for single houses. There's a national law saying that 65% of renewable share should be in new heating systems in houses, or they should get connected to district heating. And the district heating systems have to make a transformation plan so that they are decarbonized until 2045. There are also subsidy programs like the BEW, and of course also ongoing R&D work, and the national funding programs for R&D are also important because here best practices can be built and shown, and the knowledge transfer can be made to different target groups. For example, in these two websites, we did a lot of information work, and something you can see there, some documents and also videos and so on. There's also a FAQ and different documents and information. Of course, for communities, it's always important to find the areas. And this is also a big issue in Germany. And it's important to know that areas with solar fields are like upgraded ecological. So it's they are not sealed or not lost, but the biodiversity will be more than before in most cases. And we are researching about how can district heating with higher temperatures be delivered with solar thermal. For example, here with concentrating solar thermal, like parabolic trough collectors, or other concentrating technologies, it's possible to have higher temperatures. And this is also important to decarbonize the existing district heating networks. We made an overview of technologies in the task 68 in the IAA program. Maybe you want to have a look there. There are also many other documents and deliverables like about digitalization, about monitoring, but also about the economics of solar district heating, and so on. And there's also an info package for towns and cities. Maybe this is also interesting for you. It's also linked to a German research project. You can find here more information if you like. So this was a short overview, and I'm looking forward to questions if we have more time.
Thank you very much, Magdalena, not only for giving us a German perspective, but also zooming more broadly on the global level, thanks to the work of Solar Heating and Cooling Technology Program work. So now we move to the question answers time. If you have, I see that some colleagues have already put some questions in the chat, but we were keen to maybe talk about a couple of examples of topics which are needed for us to help, namely the permitting and access to finance. Just let me share my screen now again. Okay. So here is Q&A time. Yeah. So for the Q&A, please put them in the chat. There is a first slide which or visuals that we wanted to show here, which was about the average time that is needed for a large-scale solar heat project, where you see the initial contact, pre-feasibility, feasibility from 3 to 12 months, but then the big chunk in the middle, 2 to 4 years, is the development phase, including commercial negotiation, technological options, but permitting, land use, subsidies, and financing. And then when this is done, the construction, testing, and start of the delivery of heat is much faster. So maybe can I, as questions get answered, and of course, if we may not be able to answer them all during the time that we have left, but if I can just have some reactions from the colleagues on the issues relating to permitting, access to land. Can I invite the speakers to comment on that topic of permitting and access to land? That would be a first, proposal for the Q&A exchange.
I'm happy to start the discussion on this land and permitting issues. Maybe just one important thing to stress is that for solar thermal projects, the pressure on land is specific. Why? Because we need to be nearby the heat off-taker. So basically, the land pressure issues is that we are in competition with all different specific land uses, because very often we are in dense areas where other projects want to be developed. So that's the first thing. And so in this context, of course, there is a strong permitting challenge when we talk about the zoning, the urban planning issues. And I think that's pretty much the case for all renewable projects. But specifically for us, there is an urgent need of simplification. I think there is an awareness, a lack of awareness, and we've mentioned it today already, but simplify procedures in that matter for projects which need to be in specific land plots. I think that's very a key fact. I'm happy to leave my colleagues complete.
If I may say something too, it's not easy to find the land nearby. That's one important constraint that brings me to say that spatial planning in cities is what we really we need to address, because typically, given the fact that solar district heating is not so widely known, it's a very special case when the local authorities imagine that some area should be dedicated to a solar thermal plant. The other issue is that anyway, if you find the area, you need to connect it to the network. And it's not always the case that the network passes nearby. So one important aspect, which we had to solve, by the way, in Groningen, is to create sufficient tools, financial tools, to support not only and not just the solar plant, but also the connection. In the case of Groningen, we built a 1 kilometer connection from the plant to the heating central of the city. So spatial planning and connections are what makes us a bit different from photovoltaic, which basically requires land anywhere electrical connection can be reached.
Yes, I'm sharing the screen now. I can't see, unfortunately, the questions coming in, but before sharing, I could see that there was a comment by someone about the cost of PV versus the cost of solar thermal, and how could we maybe, which learning to take from that, and how to help lower the cost of solar thermal. Anybody wants to take that? Now we have only a couple of minutes left before concluding to keep to the 1 hour. The cost of
I
technology.
would like to say this about PV. The scaling up of PV and the cutting cost by 20% per year compounded was done in China, where they have integrated the whole supply chain. And it was possible because they started from an extremely high price. That was the price of PV like 30 years ago. With the consistent investment strategy, they got us where we are now with PV. This is not necessarily possible with solar thermal, where we are not starting from an extremely high price. Solar thermal is already competitive with the fossil fuel costs and heating costs from fossil fuel. So I guess we can do, and we are doing something to reduce the costs, but there's no case that we can follow the same path, because they are two completely different models and two completely different products.
Yes, maybe I want to add, because many people don't know, two different products with two different efficiencies. So solar thermal has 3 times the efficiency of a PV in the same space, or 3 times the yield. So this is important to know, especially if space is limited.
That's right.
Thank you.
One addition, maybe, if you're interested in more economics of solar district heating, you can also check out the IEA Task 68 report about the economics of SDH. Colleagues of mine work there about how the costs can be reduced. So maybe you find some new information there.
Yes, there was a question on the economics, indeed, of that. Anybody else has a question? I'm just checking the chat now. Yeah. The ratio storage volume solar collector surface. Anybody wants to take that one?
I don't know if the poster was thinking about our plans, but the way anyway, every time we design a storage system, we look at their load curve, the client's load curve. If we can, and then we match it with our production. And the size of the solar thermal storage is determined by the matching of these two curves. For example, in the case of Groningen, the 6,000 cubic meter storage comes out of the needs that they have in the summer, and so the maximum that we can deliver during the summer is 24 hours of heat, and therefore this is what we had to store.
Okay, well, thank you again to all the speakers for their respective case studies. We will make all this recording available, and on the website of SolarHeat Europe you have many more examples. But just because this webinar was planned for 1 hour, I will now come to the conclusion. which is that for us, we have really 3 key takeaways: that solar thermal district heating is mature, scalable. It can work from the north to the south of Europe. We saw already the vast number of solar thermal district heating in Denmark, and we see different sizes of different projects across Europe and of course worldwide. So this is a ready to develop technology. It's very impactful. It works extremely well with other technologies, other energy sources, hybridizing with heat pump, making the whole system even more efficient, coupled with solar thermal energy storage. So really looking at it in the mix of technologies and making the most of this mix is really good. And of course, EU, national and local actors have a really key role to play to really help the awareness, help the planning, help access to land, help also the financing. So the financial community with regard to de-risking and support for investment is really key. So as we implement the package of Fit for 55, Renewable Energy Directive, Energy Efficiency Directive, and as we prepare the heating and cooling strategy, there is a lot that can happen at all these different levels. So with that, I would like to thank you all for attending the webinar. I would like to thank again my speakers, Mathieu from the Commission, and looking forward to pursue the conversation at SolarHeat Europe level, EHP level, and of course on a one-to-one basis with all the commercial companies available to answer your requests. Thank you very much.
Thank you. Bye.